Hi there, this is Mr. Delvet, your physics teacher. Today we'll be looking at turning effect of forces. The key points in this lesson is that you have to understand that the moment of a force about a point is a force times a perpendicular distance along, along the line of action about that pivot. Its force is moment of a force about a point is a force, the product of the force times the perpendicular distance about that point. Right. And there are two factors that affect moment of a force. We have the force, one, and we have the perpendicular distance. So it means that if you increase the force, you increase the moment of the turning effect, because turning effect is moment of a force. If you increase the perpendicular distance, you're also increasing what turning effect. And we have many applications of turning effect in our day-to-day activities, like using a spanner to untie bolts. You see, the longer the spanner, the easier the turning effect, because the longer the distance, the longer the turning effect. So that's what we say. And you also apply this idea also in opening a door. Opening a door has experience. You apply the concept of turning effect. Sorry. Now we also, how do we get the moment of a force of a whole system? The moment of a force is given by the sum of the anti-clockwise moment plus that of the sum of the clockwise moment. So we have this is the sum of the anti-clockwise moment plus that of the um, this not there plus that of the clockwise moment. But you see, I put a negative sign because we consider the anti-clockwise moment under this for a moment as positive, while the clockwise moment as negative, because moment of a force is a vector quantity. Good. Now, couple is are forces that are equal and parallel, but they are moving in opposite direction. Take note, they're equal, they are parallel, but they are moving in opposite direction. And now, what are examples of couple that we have? Like you steering a car or riding your bicycle, you have your two hands. Or when you steering a car, the right hand might be going up, while the other one is going sideways. So they cannot be going up at the same time. One is going up and one is going down. And so they up and down, but they're having the same, they're applying the same force. So a couple example is good example of couple is when you're steering a car or driving. Your hands apply couple. They are two equal forces, but they are moving in opposite direction. The moment of a couple, because couple is a force, so the moment of a couple is called a torque. It's called a torque. A torque is, now the formula is force times the distance between the two forces. So if I have something like this, and this is it, and this is it. Now this is force 1 and this is force 2. So the distance between these two forces is t. So now, so the torque, the moment of a couple, these two are coupled because they're equal, but they're opposite. And because they're opposite, our torque now be force times the distance. Now, when the system is in equilibrium, and that most of the cases in your level that we're talking about, when the system are in equilibrium, there are two conditions that suffices. Means that the sum of forces acting on that system is zero. The sum of forces acting on that system is zero, and the sum of moments is zero. And when the sum of moment is zero, it leads also what the principle of moments. And the principle moment states that if the system is in equilibrium, the sum of the anti-clockwise moment must be equal to the sum of the clockwise moment. And in most of the problems that will be seen in your level, in grade 10 or lower classes, will be they'll be applying the principle of moment. And you need to know how to state it, that the sum of anti-clockwise moments must be equal to the sum of the clockwise moment. So now at your level, they'll be mostly asking questions at about about how to calculate moment, about using tool like they'll give you that, okay, there's a force and there's a perpendicular distance, calculate the moments, and they'll also ask you to, you need to know how to calculate the moment, and they'll also ask you to, they'll give you a system and ask you to calculate the weight of a body when placed at a particular distance, right? And when placed at a particular distance, this system will be in equilibrium. So calculate the weight of this body. Or attempt to actually calculate the distance itself. They can actually calculate that distance actually. So those are the different cases that you'll be seeing as we'll be studying. They'll ask to calculate the distance, or they calculate the weight, or they ask to calculate the moment of the force. Now, and most of the times when they actually calculate the moment, the system might not be in equilibrium. But if they actually calculate the weight of the body or the distance, they'll always tell you that the system is balanced or the system is in equilibrium. So let me explain what I was saying in a factual sense, like in with diagrams. So in every system, for example, we have a bar, like a seesaw. All of us have done seesaw, right? When we're in primary school. So we have this, and there's always a pivot like this. This is what we call pivot, like a small stick that you put one person sitting here like this, another person sitting here. That's what we're talking about, right? And they are making seesaw. Now, this person goes up and this person goes down. But if this people are system, so now this person apply the force, there's a weight of this person, W1, and there's a weight of this person, W2. Now, they said this is a point which is a pivot. That's a point which is a pivot. And we are saying that the distance between this weight and this pivot is what we call the perpendicular distance. That this distance, this L2 and L1, is what we call the perpendicular distance. So now this, when you are moving like this, you will call anti-clockwise. When you are moving like this, is clockwise. So anti-clockwise, clockwise. So when you're moving, when this man, if I put my hand here, you see that this man will move like this. If I put my hand here, you see that if I want to pull this force, it will move like this. So that is moving in the clockwise direction, and this one is moving in the anti-clockwise direction. So if you want to get the moment in the axis, so the anti-clockwise moment will be equal to with the weight, which is a force, times the perpendicular distance, which is L1, so the distance between this force and this pivot. Now, if you want to get the clockwise moment, will be equal to the weight W2, which is a force, times what the distance between the force and this pivot, which is times what L2. So that's the clockwise moment and the anti-clockwise moment. So if the system is not in equilibrium, your total moment will be equal to the sum of the anti-clockwise moment plus the sum of the clockwise moment. So now we have W1, L1. Now we will see that the clockwise moment must be negative, so it will be minus W2, L2. Because we say this one, this vector sum will be negative and this minus what? Positive. So that's how we do the normal calculation. But if they are in equilibrium, it will tell you that if the system is in equilibrium or balance, they will have the sum of the anti-clockwise moment will be equal to the sum of the clockwise moment. That's what it means that W1 L1 will be equal to W2 L2. So that's what you're going to do if they are in equilibrium, right? So there might not be only two forces, there might be 3, 4, or 5 forces. That's what the sum of the anti-clockwise, because there are cases that you will not see just one force. You might see 2 or 3 people. You can see another person standing here. You can see another person standing here. Or you can see 3 people standing here and then 1 person standing the other way. So it depends. but you need to know which are the forces that are acting in the clockwise direction and which are the forces that are acting in the anti-clockwise direction, and what are the distances from where the pivot is being taken, where the pivot is being placed. Okay, let's look at some examples, please. Okay, look at some examples. Okay, I look at this example like this. Sorry, take some time. Okay, for example, you have a uniform beam of metal along a 40 centimeter long pivoted at 22 centimeters mark. This beam is used by the cocoa buyer who places a 50-gram block at the 0 centimeter mark and a back of cocoa at the 40 centimeter mark to have it balanced horizontally. So what you have to notice is that the synthesis is balanced. So what you have to take note is the beam is uniform. Then what's the length? Is 40 centimeter long. And where is the pivot? The pivot is placed at 20 centimeter mark. And they said the cocoa is used to place a back of 50 gram at the 0 centimeter mark and the back of cocoa at the 40 centimeter mark to have it what? Balance. Means that when you say balance, it means that the system is in equilibrium. So the first thing is that you draw the diagram. So in drawing the diagram, we have this is a uniform beam like that, and I said this beam, the length of this beam is 40. It means that from here to here is 40 centimeters, and it means that it starts from 0 to 40. That's what it's saying. Now they said it has from 0 is pivoted at this 22 centimeter, means that the pivot is placed at the 22 centimeter, means that I will count, means that from here to where I have 22, it will not reach the middle, it will pass the middle, but this might be the middle, 22 somewhere here. So the pivot is placed here. Let's see. So it means that at this point we have this will be 22, right? Okay. Now I said now the back is placed. This cocoa is who places a 50 gram at the 0 centimeter. So they put the back here at the 0 mark, the 0 centimeter mark. So let me use another color. So we have here 50. Now you will not put 50 kilogram at this point because this one indicates the weight. So what you have to put by the weight. So if you have this one here, this value here is the mass. So how do you get the weight? You multiply this value by 10. So instead of having 50, you have it 500 newtons. So take note, when they give you, they'll give you your mass, the mass, the values here in mass, in kilogram, but you have to always convert them to weight before you are applying it in your equations, because the moment of a force does not talk about mass, it talks about what? The force, and force is already force, and weight is a force. So you always have to convert your masses to what? Weight. Okay. Now, the next thing is that a bag of cocoa at the 40 centimeter mark. So they have not tell us what was the mass or the weight of that bag, right? But they say something was placed at the 40 centimeter mark. Let's say it was X. There was a bag that was placed there at the 40 centimeter mark, but they have not tell us the weight. So that's what we are going to look out for. We are going to calculate now this mass of this bag, because now they're saying when they place this mark at the 40 centimeter mark, this thing was balanced, means that it was balanced, means that it became what? In equilibrium. So this is equilibrium. It become in equilibrium. So it becomes in equilibrium. Now, what is the distance between now the 500 and the pivot? So we have to calculate our distances. We have to now look at our distances now. So make sure you always draw your diagram, please. So your distance from here to here will be what? 22 centimeters. From here to here, what will be? Think it will be 18 centimeters. Right, so those are our distances between the 500 and an x. So now since it's in equilibrium, what do we say? The principal moment, sum of anticlockwise moment, is equal to the sum of clockwise moments. So what's our clockwise moment and sum of anticlockwise moment? So you see this man is our anticlockwise moment, and this our man will be our clockwise. Right. So what do? We take 500 now, will be 500. So we have the force 1 times G1 will equal to the force 2 times what? G2. So the first one will be 500 Newton times 22 centimeters will equal to F2, which you don't know, X times 18 centimeters. We make something the subject, we divide both. What do we have? Take this one this way. We have 500 Newton times 22 centimeters over 18 centimeters, which should be equal to X. So this 18 cancel this 18. You're left with 2 here, 9, 2 here, 11. You're left with 5,500 or 9 Newton is equal to what? X. But now, this value is weight. This is your weight. But what now is the mass of the bag? The mass of the bag now, you're going to use a formula. Weight is equal to mass times what? Gravity. And to make mass a subject, you have weight on what? G is equal to M. So now you see that the G now, your mass will be equal to weight, which is 5,500 divided by 9 newtons divided by 10 meters per second squared. So you see your mass here will give you 550 or 9 kilogram. So that will be your answer of your mass of the bag if the system is in equilibrium. Okay, let's look at another problem and let's see how it goes. Okay. Okay, let's look at this one. Okay, look at it. A metal rule AB of mass 100 gram is pivoted at the 30 centimeter mark. A mass X is suspended at the 0 centimeter mark. Gives the metal rule a horizontal equilibrium position. So they have said, you see that, to take note of the word equilibrium position, means that it's in equilibrium. They talk about the rule AB. They have given the mass of this ruler, and they say it's pivoted where at the 30 centimeter, and they're asking to look for what? This mass X. And it's suspended where at the 0 centimeter mark. So the first thing is that we have to draw our ruler, right? Draw our ruler. Let's say it's AB. They said they pivoted at the 30 centimeter mark. So it's pivoted at the 30. So they're not giving us the length of the ruler. It says pivoted at the 30 centimeter mark. Okay, they said it's a metal rule. So a metal rule, this word, metal rule, means that the length of it will be is 1 meter, means it will be 100 centimeters. Means that from here, meter rule means that it's 1 meter, right? So it means that from here to here is 100 centimeters. That's what they're saying. Means that we count 30. The 30 centimeter mark, we put our pivot. Means that at this point, this is my 30. Right? I put my pivot there. That's what my pivot is. They said at the 0 mark, they have put a width. There's a width there. The 0 mark, there is a width. So you have x. There's a width there. And they said the mass, this one, of this ruler is, they have given the mass ruler. So where is the mass? Where will the mass be placed? The mass will be placed in the middle of that ruler at the 50 centimeters. So this 30, there will be 50 somewhere. So this is where the mass of the ruler is. So it'll be 100. I said you should not put 100 gram because gram is mass. You have to convert this mass into what? Weight. And for you to convert it, you have to, this is 100 gram. You have to first convert to kilogram. So we give you 0.1 kilogram. So now, so for weight now will be mass times gram. Will give you, and times g will give you 0.1 kilogram times 10 will give you 1 newton. So that is the weight. So you put a 1 newton here. So that's how it is. So you have the weight of the ruler, and then you have this mass that you don't know. And they said the system is in equilibrium. Equilibrium. From this understanding. So from that, it implies that the sum of anti-clockwise moment will be equal to the sum of the clockwise moment. So you see, this man will be the clockwise, and this man will be the anti-clockwise. So you have x times what's distance? We don't know. So this is distance from here, and this is distance from here to here. So distance from here will be 30. Here the diagram. Distance from here to give you will be what? With 20, because you have this 50 minus 30, you have 20. Distance between the pivot and this point will be 20. So you have x times 30 centimeters will be equal to 1 newton times 20 centimeters. So divide both sides, divide this, and then so this one comes this way. You have x will be equal to 1 newton times 20 centimeters over 30 centimeters. So this one cancels this, 0 cancels this. Here x will be equal to 2 on 3 newtons, will be same as 0.7 newton. So that is the weight, but they're asking for what? Mass, not the weight. So x now, so the mass, you see W, the weight is equal to mg, and then we divide, we have W on G is equal to m. So it means that 0.7 newtons on 10 meters per second squared will be equal to what? M. So you have 0.07 kilogram is equal to what? The mass. So the mass will be equal to 0.07 kilogram. That's how we solve problems like this. Thank you for watching, and if you have worries or doubts, you can put in the comment section, or if you want us to continue helping you solve to understand these topics, you can click the link to my WhatsApp group in the description below, and so that we can better serve you. Thank you for watching, and stay tuned and subscribe to the channel so every new video you get a hint, you're alerted to come on to watch what I have posted or uploaded. Thank you so much.